Hello class, picking up where we left off at. We're on example 2. It says solve. Write the answer in inequality graph in an interval notation. Now what we have here is what is called a compound inequality. If you notice, we have two inequality symbols here. We have 7.3 is less than 5.8 minus 2.4x, which is less than or equal to 13.9. Now, there are a couple things I want you to realize here before we go through and solve this problem. Now, the first thing you need to know is the order in which this goes. The smallest number always goes to the left, the variable is in the middle, and the largest number always goes to the right. Now, as you're solving the problem, it may not appear to be that way, but when you write your final answer, you must have it in this order. Smallest number, variable, largest number. Okay, now, this is the next thing. When you solved an equation, just like this, I'll put this as an example. If we had x plus 2 is equal to 5, we will subtract 2 on both sides, and we will have x is equal to 3. That is because of the golden rule of algebra. What you do to one side of an equation, you must do to the other side. Now, this inequality has three sides. So what you do to one side, you must do to all three sides. Now, what we have to do is the same thing we did in this equation here. We need to get the variable by itself. So we go here in the middle. So the first thing we need to do is subtract 5.8 on all three sides. 7.3 minus 5.8 is 1.5. We bring down our inequality symbol. We'll be left with negative 2.4x. And it's less than or equal to 13.9 minus 5.8 will give us 8.1. Now we have to get rid of this variable. This number that's connected to the variable. So we'll divide all three sides by negative 2.4. Now, when we divide this, 1.5 divided by a negative 2.4 will give us a negative 0.625. And because we divided by a negative, this inequality flips around. Now we have a negative 2.4x divided by negative 2.4. That will give us x. And we have 8.1 divided by a negative 2.4. So we know that inequality flips around. And 8.1 divided by a negative 2.4 will give us a negative 3.375. Now we need to rewrite this inequality so it's in a proper order. We know that negative 3.375 is less than negative 0.625. So we'll put our x in the middle. Our negative 3.375 will be on the left-hand side, and our negative 0.625 will be on the right-hand side. Now we have to determine the inequalities. Now, if you notice in the original problem, the greater than symbol or the opening was towards the variable here. So now this inequality symbol here is the one that's opening towards the variable. So we will write that here. It'll be less than or equal to the x. And then the one that is pointing to the variable, which is this one here, we will write that here. And we will have to write it pointing to the variable. So basically, this is how it goes. The lowest number, the inequality pointing towards the lowest number, the variable, the inequality pointing towards the variable, and then also the larger number. Okay, now, this is our inequality. Now we have to do graphing. Now, what I'm going to do with the graphing is this here. I'm going to do two graphs. I'm going to explain to you why I'm doing two graphs in just a second. Now, as you know, with the graphs, I always like to have 0 somewhere on the graph. And since we're dealing with two negative numbers, put the lowest one here. Actually, yes, the lowest one goes here. We have negative 3.375. And we know the highest one goes here, negative 0.625. Okay, now, and we can do the same thing here. Okay, now, in this graph, we're going to use the open and closed circles. Okay, now, with the negative 3.375, because this is less than or equal to, we know that this would be a closed circle. Next, this other number here, this negative 0.625, we know this is a regular inequality, so this would be an open circle. It is not included. So then what we would do here, and I'm going to change the color, we would connect them. Let me use black, just so you can see that we're connecting them. Okay. And that's it. There's no arrowheads here. That means that it starts here, and this is included, and it ends here without including the negative 0.625. Now, we go down here. Now we're going to use the brackets and parentheses. So with this negative 3.375, since it's less than or equal to, we will use a bracket on here. And then since this negative 0.625 is not equal to it and not included, we will use a parenthesis here. And then just like in the other problem, we will connect them. Now this is the way how you graph. You either graph using the closed circle, open circle, or the bracket and parenthesis. Now, the last thing that they want us to do is the interval notation. Now, we know with interval notation, we know we're going to use the negative 3.375. We always start with the lower number, and then we will have the larger number, which is negative 0.625. And since this negative 3.375 is included, we will put a bracket here. And since this negative 0.625 is not included, we will use a parenthesis. So these are your answers here. I'll just circle all of them. These are your final answers. This is your inequality. Depending on what graph, I should put or. Depending on what graph you're using, you either have to use the closed circle, open circle, or the bracket and parenthesis, and then also the interval notation. So this is your final answer for this problem. Now, we scroll to our next problem. It says, example 3, the function f of x and g of x are graphed below. Use the graph to find the values. Use interval notation where necessary. So the first thing it says here is find x when f of x is equal to g of x. Now, basically what this is saying is when f of x, which basically they're talking about your y values, is equal to your g of x y values, and that is here. Well, actually, this is where they intersect at. So when f of x and g of x is equal to each other, that is when x is negative 4. When x is negative 4, this is where they intersect. Okay, now it says find x when f of x is greater than or equal to g of x. So now, remember, this is basically comparing the y values, but they want us to talk about the x values here. So if you look here at this graph, you will notice when we go from left to right that the f of x is increasing in our y values. So what happens here after we find where they intersect at, the f of x is actually greater than that. So what we will write here is, we will write f of x, or we would say x is greater than or equal to negative 4. Now let's go back through that again. Okay, this is where they intersect at. But every x value past this negative 4 actually has your y value greater than your g of x. Now if you look from left to right, so this is negative 4. When x is negative 3, you know that your y is higher than your g of x. X is negative 2, your y value is actually greater than your g of x. So this is your final answer for B. Now, if you want to write this in interval notation, You have a bracket. It'll start at -4 and it'll go to infinity. Now we go to C. It says find x where f of x is greater than g of x. So we would basically use this same inequality, except for we would take the or equal to off of it. So it'll be x is greater than -4. Because we know at -4, the f of x and g of x are equal. But everything greater than -4, f of x is greater than g of x. So our interval notation, we still would start with -4 and we would go to infinity. But instead of a bracket, it would be a parenthesis because -4 is not included in this answer. Now we go here to D. It says find x where f of x is less than or equal to g of x. So that means we want to find f of x where g of x is greater than the f of x. So we look here at our x. Now we know we're going to start here at -4. Now, if you look here, when we go where x is less than -4, we know that f of x is actually less than g of x. Because if you notice, you would go down as x is less than -4. So x is less than or equal to -4. Now, when we do this as interval notation, we would start off from -infinity, and that would take us all the way to -4, and the -4 is included. Okay, now we go here to E. We have f of x is less than g of x. Okay, now it's basically the same concept that I told you before. It'll be x, but this time it'll be just less than -4 because g of x is greater than f of x for all values less than -4. All x values less than -4 because at -4 they're equal to each other. But all x values less than -4, your g of x is actually greater than your f of x. So our interval notation would be, we have our parenthesis, -infinity, comma, -4, and we would end it with a parenthesis because the -4 is not included. And that is it for that problem. Now we start on example 4. It says a table with several values of two linear functions is given. Use the table to find the values. Use interval notation. Now, we have this table here. We have f of x is equal to 6x plus 12, and g of x is equal to -2x plus 4. Now we have A here. It says solution to the system. Now we have y. Now we know this y represents f of x, and we know this y represents g of x. So we have y is equal to 6x plus 12, y is equal to a -2x plus 4. Now all we have to do is find where their y values are equal to each other. We have an x value of -1, and we see where the y values are equal to each other. So we know the ordered pair for f of x is -1, 6, and the ordered pair for g of x is -1, 6, where they intersect. So it'd be -1, 6, and that is the point. Okay, now we go to B here. It says find x where f of x is greater than or equal to g of x. Now if you notice here, for f of x, if we look at our y values, starting after -1, you notice that when your x is increasing, all of your f of x values are greater than your g of x values. So what we will have here is we want to go where it's equal to or greater than g of x. So we would need all x values that's greater than or equal to -1. Because at -1, they're the same, but when you go greater than -1, your f of x is greater than your g of x. Now if we wrote this in interval notation, we have our bracket, because the -1 is included, it'll be -1, comma, infinity. And that is it for that problem. Now, we scroll here to example 5. It says a t-shirt printer charges a $150 setup fee and $4.50 per shirt for a t-shirt with the company logo printed on it.